Howdy. I'd like to do a demo for this critical design review. So Ben, if you'll bring the camera over here. The first thing to show off is our breakout board. It takes all the 44 pins on our PIC and gives us access to them so we can wire it up to a breadboard. This port right here is used for the programming. We use the ICD2 to do that. Over here we have a port used for UART, which we use the PIC-Kit 2 and the PIC-Kit 2 software's UART tool to see text that is transmitted and received from the PIC. Over here we have a wireless port. That's for testing right now. We currently don't have that feature working. Over here we have our accelerometer that is connected to an op-amp that we have wired as a voltage follower. It acts as a buffer because the impedance coming out of the accelerometer is 32 kiloohms and the PIC pins can only handle 22 kiloohms. So we have 3 of these yellow wires, they are our analog going into here. Over here is our other analog wire connected to this potentiometer that we're going to use to simulate the battery voltage. Over here I have a 5 volt and 3 volt regulator setup that we use to power everything except for the op amp, which requires 5 volts. On the final board we'll be using a op amp that uses 3.3 volts. So I'm going to direct your attention over to this white space right here, and I will power on our device like that. Okay, and you're going to see this nice fancy logo done in ASCII, and it's telling us that if we type help we get a list of commands. So I'm going to type in the word help using this macro. Alright, so we have a few features. We have a time and date setting feature, reading the analog voltages for X, Y, and Z and the battery, the ability to log data, and a toggle LED function. So the first thing, let's read the time. So we can see it's 1/1/2010, 12:35:25. When I initialized the device, I set it to January 1st, 2010, and it is 12:34:56, and you can see some time has passed since I turned on the device. So let's set the time, and right now it is 5:56, so the 5:56 and 0 seconds. Alright, and I'm going to set the time, and it tells me I set the time to 5:56. So let's set the date. It is 10/14. It is the 4th day of the week, which is Thursday, and it's 2010. Alright, and I'm going to set the date, and now you see that the date has been set. Let's read the time one more time. Probably a few seconds have passed, and you see a few seconds have passed and it's still the right date. Alright, so let's go back to our help menu, and we can see we have the ability to read analog voltages. So let's read the x-axis. Read analog x. Okay. So the x-axis is a little off, as you can see over here. Let me push that down. Alright, and I'm going to read it again. Okay, come over here. So it said 0.194 Gs. That's because it was slightly tilted, but now it's more level. So now we're closer to 0 Gs. Okay, so the x-axis is laying flat, so there's no gravity pushing on the axis. Alright, I can read the y-axis, which is about the same. There should be 0 Gs on the y-axis because it's laying flat, and you can see we have negative 0 Gs, so it's very low. Okay, so the z-axis, which has gravity actually pushing on top of it currently, since it's laying flat. So we have almost it's about 1 G on the device, and you can see how many volts we're reading and the ADC value that we get out of it. Alright, the next thing to show is we have an analog channel for the battery, so we can see what the battery voltage is. And we see that it's at 80% charge because it's 2.6 volts. So Ben, you can watch, and I'm going to change this a little bit. Let's make it go down a little bit, and I'm going to read again. Now we're at about 70%. This is going to be useful later in our device to report back if the battery is getting low. Okay. Next thing I have to show is the LED. So if I want to toggle LED 1, And Ben, I want you to focus on the red LED on the board. So I'm just typing in toggle LED 1, and whenever I send a command to the PIC, it knows to turn on the LED and then turn it off. So, very exciting. Alright, and finally we have one more demo, which is the log data demo. Now this is just a script that shows me what the X, Y, and Z axes are at currently, and I do it for 50 counts, so just 50 reads. So it's going to show me the timestamp, and it's going to show me the G's that are on the accelerometer. And I'm going to run this real quick, and you can see we're getting a whole bunch of data. The x-axis is close to 0, the y-axis is close to 0, and the z-axis has 1 on it. Now I'm going to run the same script again while moving the board. Alright, so we can go back and we can see that the x-axis is going towards the positive g direction, and then I went back down flat again. The z-axis didn't move too much, and the y-axis, see, I moved it around just a little bit. That is currently all we have right now for the demo. I'd like to thank you for watching.